Welcome to a new lesson following the spring break for 2014. And we are going to begin by actually finishing up Chapter 10, which we didn't do before. So we're going to go ahead and take a look at Section 10.8, which is going to introduce us to the world of imaginary numbers. Now, we'll see these to a limited amount in this course. They are going to emerge in something in the work that we do with quadratic equations. Some of the solutions that we're going to find for quadratic equations are not going to be in the real number system, and that's a system up to this point you've always been working in, from grade kindergarten to now. But now we're going to begin to go into what is known as the imaginary number system. So, an imaginary number so what an imaginary number is I forget the scientist's name who did it. It may have been, it was an Euler. I think it was someone else, maybe Gauss or someone like that. They wanted to find out, how can we find the square root of a negative 1? We've talked about before that there's been no way to do this. And usually what you'll see in the textbooks as what they specifically say about it is that there's no real solution. And that's true. So there's not a solution in the real number system. So what we have is we have a solution for this in the imaginary number system. So let's take a look at what this is. So if we take a look at the square root of negative 1, essentially this is what's going to be equal to I, and that's a lowercase I. So this is by definition. So basically this is something that mathematicians came up with as a concept to represent the square root of negative 1. So we represent this with I. So let's go ahead and expand on this a little bit, kind of taking advantage of the properties of radicals that we've worked with in earlier parts of Chapter 10. So what would happen if I were to take the value in I and I were to square it? Well, if I take the value in I and I square it, just like if I do that here, I will find that I squared is going to be equal, well, let's see, the square root and the square undo each other. So another property is we can say that I squared is equal to negative 1. So you may wonder, what do we multiply by itself to get negative 1? It's going to be I times I. So we're going to use these two properties here to work through a series of questions and see what comes about this. Now, the math here is not necessarily difficult, but because we're looking at something that we term as an imaginary number, it's going to just sound a little different. It's going to feel a little unusual to you at first. So we'll take a look at how to kind of simplify some of these questions, and let's go from there. So let's begin by taking a look at question number 9. So we start with the square root of negative 100. Okay, so well, the long way of kind of doing this is I could write this if I wanted to, is negative 1 times 100, which I could write as radical negative 1 times radical 100. And then I could say that the square root of 100 was equal to 10, and that the square root of negative 1 is equal to I. And yeah, we usually don't write it as I times radical 10, we usually write it as 10I. Okay, so let's take a look at a similar problem. Let's take a look at how the notation plays out for this. So let's say I have the square root of negative 19. So what you may realize is that 19 is a number that's not a perfect square. We can't find any factors for 19 because it's prime. So the best we can do is to write this answer one of two ways. We do know that the square root of negative 1 is going to be I. So instead of splitting this up into two parts, like underneath one radical and splitting into two radicals and then going for the answer, we just say, okay, we know I is going to come out of this. And when I comes out, the negative comes from underneath the radical. So I can write this as either I radical 19, which is one way of writing it. The other way to write it is radical 19I. Now, this form is a little different than what we have up here. This, generally speaking, is more of the accepted form. As you will see later, we're going to be looking at combining a real number and an imaginary number and making what's called a complex number. So when we write a number in complex form, we're going to have the number in front here with the I to the right. So this is not an example of a number in complex form. So this is not an example. What this is when comparing this first form of the answer to the second form of the answer, this is going to be the form that we would use when we put a number into complex notation. So we'll get into that in a little later. Let's take a look at a problem like 14, where there is going to be a little more simplification involved. So let's say I have the square root of negative 12. So one thing I could do to begin simplifying this at first is I could, let's just kind of do this the long way, just to get people more comfortable with this. I could go ahead and write this as 12 times negative 1, or which I can write as radical 12 times radical negative 1. Well, after that, I could take the radical 12, which is going to be radical 4 times 3 times radical negative 1. And I know the 4 is going to come out as a 2. So this is going to come out to be 2 radical 3. And then I can put the I up front. You can also write this if you want to as I, or 2I radical 3. So there's two ways to write this. You can write this as 2 radical 3I, or you can write this as 2I radical 3. Again, if we're going to put a number into a complex form, this is the form we're going to use later. You may also see it in this form. So just depending on the teacher you have, on the textbook you may use in the future, on the work that you're doing in MyMathLab, just recognize that both forms are used by mathematicians and both forms are acceptable. On any one of my tests, I don't care which form you use, except when you're asked to write an answer in A plus BI form, which is the way we write complex numbers. So right now, the number we have here, these are all simply imaginary numbers because they all contain an I in one term. So let's go ahead and continue to go forward on simplifying some more type of work here. Suppose I have a question like 16, where I have a negative on the outside, and I have something like radical negative 17. So what happens in this case here, we're going to just kind of forget about this negative on the outside a second. But I know radical 17 cannot be simplified, so I can write this as negative 17 I, or radical 17 I, and then the negative comes through, so I can write this now as negative radical 17 I. You may again also see it as negative I radical 17, but it's not like the negative underneath the radical here undoes anything with the negative outside the radical here. They don't undo each other. This has to be brought from underneath the radical, and it's going to come out as I. So just as a shortcut, this takes a little getting used to. With the work that you have on MyMathLab, you should be able to get more comfortable with it. Let's go ahead and take a look now at number 20. This is going to be negative the square root of negative 75. So at this point here, I'm going to begin to treat this a little more like a standard problem. So I'm going to go ahead and I'm going to split this up as negative. And I'm going to write this as 25 times 3 times negative 1. Now, what are the pieces that are going to come out? The 25 is going to come out as 5. The negative 1 is going to come out as I, so I should be able to simply write this as negative 5 radical 3 times I. Now, again, if you wrote this as negative 5I radical 3, I would accept that as an answer. You're going to see that I will focus on this form of the answer so that when we go to complex numbers, that form should not be too difficult to transition to. Okay, let's take a look at just a few other questions here. So we're going to take a look now at the following problem. So we've got 22. A little bit of a math problem with these here. This is going to be 4 minus radical negative 60. So in this type of a problem, we have a real number being added to what's going to turn out to be an imaginary number. So the type of answer that we're going to get here is going to be a real plus an imaginary. And let's see what results. So again, nothing we can do with a 4. The best we can do to simplify 60, we know that 60 is 4 times 15. That's the best we could do. So I'm going to write this as 4 times 15 times negative 1. I know the 4 will come out as 2. I know the negative I is going to come out as, or negative 1 is going to come out as I. And 15 is not going to come out of this at all. So this is going to be 4 minus 2 radical 15, and that's going to be I. So here we have a real number plus an imaginary number. So when we have a real plus an imaginary, this is what we regard as a complex number. Just when you thought numbers couldn't get more complex, they in fact do. And in fact, we have an official way to describe a complex number. So we take a real number that is now you know this says plus, it could be plus or minus. You may think of this as plus a negative, for example. A real plus or minus an imaginary number is going to make up what's called a complex number. And when we write a complex number, we're going to write this in A plus B I form. So this is just a generic form that describes how we write a complex number. So in this case, the value of A, the real number, is going to be 4. The value of B is going to be a negative 2 radical 15. And that's the value that gets placed next to the I. You'll pay special note that in all these instances, I have made the radical short enough so that the I does not appear underneath it. So you should never write the I underneath the radical. Okay? So when we take out the negative from underneath the radical, that I needs to remain outside the radical. So just a little important notation issue that we may come across later. Let's take a look at a few of the little problems like this and see what we can do with those. So we may come across a problem that looks like this. For example, number 25, what the heck. This is going to be radical negative 18 minus radical negative 100. Now, just looking at this here, you may realize that, well, the square root of negative 100 is 10. Well, the square root of 100 is 10. But because this is going to be negative 100, this is going to be negative, this is going to be not negative, but the square root of negative 100 is going to be 10i. Okay, now we do have a negative here, which we'll go ahead and put inside there, but that negative is going to come from here. The square root of negative 18, well, I can simplify the square root of 18, and that would be 3 radical 2. So if this is negative 18, if I know that negative 18, which I could write as radical 9 times 2, times negative 1, I know this is going to simplify to 3 radical 2. Well, I can just write this as 3 radical 2i. Now, this is not a plus bi form. We have an imaginary number here. We have an imaginary number here. And this is the most we can do to simplify it. 3 radical 2i minus 10i. The coefficients here, the rules of coefficients apply. We have a whole number here. We have a number times a radical 2 here. So we can't combine these any further than they already are right here. So that is the best we can do to simplify this type of question. The only other thing that you may be asked to do in this type of question is you may be asked to factor out the value of I, in which case you would just go ahead and write this as 3 radical 2 minus 10 times I. Or you may have the I out on the other side, for example. Be wary of the notation that they're going to ask you for in my math lab, and just know they may want the I on one side or the other side. Please feel free to ask questions in class about this if you have any. Let's begin to take a look at some addition type problems. We're going to multiply complex numbers, and we're going to put these numbers in complex form. So let's go ahead and start with question 28. So we're going to have the number of 6 plus 7i plus the quantity of 5 plus 3i. So these numbers are in a plus bi form, where a is 6, b is 7, here a is 5, and then b is equal to 3. So what we're going to do when we add these polynomials together, or these complex forms together, is simply add the real numbers together and add the imaginary numbers together. So here we have 6, here we have 5, so that's going to be 6 plus 5. That will give us 11. When we take 7i plus 3i, those are our two imaginary numbers, well, 7 plus 3 is going to give us 10i. So the result is a real number plus an imaginary number, giving us a complex number, and giving us the final answer to this question. So that's question number, whoops, that was actually 27. So if you're keeping track of your notes here, this is question 27 of the book. The question is written correctly. I just took the wrong problem from what I had intended. Let's take a look now at question 30, and let's hope I copy the correct question to this. So this is going to be 9 plus 7i. And now this is going to be a subtraction problem. So let's take a look at how this is going to change the problem a little bit. And it's going to be 2 plus 4i. So what I'm going to do, following a rule that I've taught earlier when it comes to subtracting polynomials, is I'm going to go ahead and I'm going to change the sign of this. So I'm going to grab my dark red colored pen here, and I'm going to change the sign of this, making this addition. But in doing so, when I make the addition, I need to change the signs of what's here. Now go ahead and rewrite the problem now after doing so that it shows as an addition question, but I change the signs of everything on the inside here. So I'm making an addition problem, but I change the signs here, and now I'm going to go ahead and combine my real numbers and my imaginary numbers. So we have 9 minus 2, that's going to equal 7. And here we have 7i minus 4i, that'll give me plus 3i. So there's going to be my final answer, written in complex form in a plus bi form. So remember, this a plus bi form is a complex form of a number. And why is it complex? Because if we take a number that's real and a number that's imaginary and put them together as simply as we can. Let's go ahead and take a look at a few more problems before going further into the next type of work here involving multiplication. Let's go down to 34, and we're going to take a look at the problem. Negative 2 plus 6i minus negative 7 plus I. So when we look at that problem, again, we're going to have to distribute the negative through to simplify this. So I'm going to change this to a plus. I'm going to change this to a plus. I'm going to go ahead and change this to a minus. If it helps you to take this work down properly, you can stop the video at any time and then just show how the change is done. Okay, I'm going to rewrite the problem again. Plus 7 minus I. So here I have negative 2 plus 7. So rule of integers applies here. So negative 2 plus 7 is going to give me 5. Then 6i minus I, or 6 minus 1, is going to be plus 5i. And we have our final answer in a nice simple form here. Let's go ahead and backtrack a little bit and go to 32. And let's see what happens with this problem. So here we have 5 minus 3i minus, again, 9 plus 2i. You'll find that I tend to be focusing on the minus problems because those are the ones that give students difficulty most of the time. And as I go through the subtraction problems, it also reinforces the addition. So I get to cover both issues. So now I'm going to change this to an addition sign, make this negative, make this negative. That's going to allow me to rewrite the problem as 5 minus 3i plus negative 9 minus 2i. And let's see how things combine. Well, 5 and negative 9, that's going to combine to be negative 4. Negative 3i and negative 2i is going to be combined to be negative 5i. So that's our first lesson in covering the basic rules of addition. Our next part of the lesson is going to go into the different multiplication rules, looking at conjugates, and then looking at some simple properties of trying to figure out I raised to any whole number exponent.